Okay, the last time we was here, we were talking about variables and expressions and how it deals with the language of algebra. Remember, we talked about we have to be able to translate between words in algebra. Uh, so what we mean is we're talking about either translate between words in algebra or translate algebra back to words or words to an expression of some sort. So when we left, we did assign 4 problems, and we said, well, let's take a look and see how well you can do with those 4 problems on your own. So now we will evaluate or take a look at how well you did by uh, coming up with my summation. Now, and again, because of the wording, there are so many words and so many different avenues you can go here. Just do not think that my answers are going to be written in stone. So the first one, number 1, says uh, subtraction. 4 subtract n. How can we write that? We could say, just one way is, let's see, 4 minus n is one way we can write that. Or we can say the difference, or let's use 4 less than, seems like to me that that's not going to go. Let's just go with n less than, and I want the then in, thinking as I do it. So let's just go with n less than 4. Okay. Now, let's take a look at the second one, which is a division. And we see here, we again, in an algebraic expression, we can use the quotient of t and 5, and we can also say t divided by 5. Okay. Now we have addition. I have a constant 9 being added to q, so we could easily translate this to 9 plus the variable q, or we could say 9 increased by q. Okay, the last one. Now we notice we said that here we have 3 parentheses h. This could have been written as 3h, or it could have been written as 3 dot h, but that all means multiplication. So how can we say that? We can say 3 times h, or we can say the product of 3 and h. All right, so I hope we all was pretty successful in figuring out how do we change these expressions back into words, but we'll get practice as we go forward. Now let's get to the second part. If we want to translate words into algebraic expressions, you want to look for words that indicate the action that is taking place. So let's take a look at addition. I'm going to change this. So let's take a look at addition. when we see the addition, or we know that we are dealing with additions, we want to put together or combine. So you'll see words that say put together or combine. Now notice we're putting these words back, and they can go with these words that we've talked about earlier. So we want to put together or combine something. James put together his money with Matthew's money in order for them to buy the video game. That means addition. Billy added his money with James' money in order to get another video game. So the word subtract, or the actual action subtract, we will look at find how much more or how much less the difference are. Multiplication, or multiply, the action put together equal groups. And divide, the actions separate into equal groups. So let's just go ahead and look at an example 2 and see how this works. Well, we want to translate these words into algebraic symbols. So we have Eve reads 25 pages per hour. So we want to write an expression for the number of pages she reads in each hour. So here's the way we look at it. Let's let H represent the number of hours that she reads. So H is, I'm going to put equal, the number of hours. That's the number of hours she reads. Okay, so now if H represents the number of hours that she reads, you want to think H groups of 25. Why? Because 25 is the pages we say she reads per hour. So that expression would be 25H, or 25 times H. Okay? Let's take a look at the second one. Looks like I got my second and third, so we'll make some room here and rewrite this. Way too close together. A, B, and C, so we'll just change them. Pretty simple, dude. Pretty simple to do. The act of technology. Oh, here we go. So we will call this one B, and said William runs a mile in 12 minutes. And we want to write an expression for the number of miles that Williams can run in M minutes. So let's do this. Let's let I want to change my font. There we go. Let's let M represent the total time. So M is going to represent the total time. What did we do here? What did we do here? Sorry. Okay, so we got that together. Sorry about that. We'll go back. So M represents the total time that Williams run, and we want to find out if he runs a mile in 12 minutes. We want to write the number or write an expression for the number of miles he run in m minutes. So here we are looking at m divided by 12. And what you want to think of how many groups of 12s are there in m. So this will be the quotient of m and 12, or m divided by 12. Alright, so let's see, can we go ahead and get this, the last one, and we have to, if you don't mind, we're going to use the power of the pen for C. And C says Sam is 2 years younger than Sue. Okay. Well, we say that Sue is Y years old. There we go again. I must be touching something. Sue is Y years old. We'll get this straight by the next video that we put up. So we want to write an expression for Sam's age. Okay, so think about younger. What do younger mean? Okay, so that means to me, what operation, if I'm younger, would be something like subtraction. So let's let Y be Sue's age. So Y is Sue's age, and we say that we think about the term less than, and it says Sam, since we're trying to find Sam, is 2 years younger, so that would be Y minus 2. Okay, so again, we're just simply looking at the wording and taking our time, going through the wording, coming up with a variable, then determining what action are we going to take as far as operations from the variable. Okay, so we have come to the end of this segment, and the next time that we sit down, we will talk about not just writing expressions, but evaluating expressions.